Okay, in this video for pre-calculus, we are in Unit 8, right triangles and solving right triangles. And so we're going to address in this video the angles of elevation and depression. As the name implies, elevation means your eyes are facing forward and they elevate to look up. So your line of vision looking straight would be parallel with the ground, and then you would form an angle of elevation right here. So it would be essentially the angle is formed with the ground, and then your line of sight looking up at some object up here. So you'll notice that forms a right triangle. So we are going to use our right triangles, our SOHCAHTOA, when we're solving for angle of depression and elevation. Okay, so angle of depression, as the name would also imply, is also going to occur based on looking straight ahead and then looking down. So the angle of elevation always occurs inside the triangle, but your angle of depression does not. So your angle of depression, okay, this is your line of sight, and when you look down to an object that's down here, that is where your angle of depression would be. Okay, so your angle of depression is outside what we would consider this right triangle here. Okay, so it's outside of the triangle. So I'm going to write that right here. It's outside the triangle. But you need to be mindful of something and pay attention to the fact that because this line right here cuts through parallel lines, that this angle of depression would be congruent to this angle of elevation right here. So, and it always works that way, so it's pretty cool. All right, so let's apply these. The most difficult part of these problems, obviously they're word problems, is going to be drawing the picture. So that is where we're going to start, we're going to start with drawing our pictures, and then we're going to use sine, cosine, or tangent to solve the problem. So for number 5, make sure you pause this and read this if you need to. We have a boy visiting the Empire State Building, and he is on a point on the ground at A. So we have a little boy standing at point A, and that is 940 feet from the foot of building C. So obviously the foot of the building, we would have a building over here, and there is going to be 940 feet between the boy and the foot of the building, or the base of the building. And we have an angle of elevation of the top, B, of the building as seen by the boy at 53 degrees. So we have got B, the top of our building, and we have an angle of elevation that is formed from the boy at A, that is 53 degrees. Okay, so that is going to be the picture that we're going to use. And this, of course, is going to be our right angle. So we are finding the height of the building. So I'm going to label that right there, the height of the building. So obviously, since that's across from 53 and this one's adjacent to 53, we are going to use tangent. So the tangent of 53 degrees equals opposite over adjacent. So we have got a setup right there for our problem. Think of this as over 1. I'm going to cross multiply, and I am going to use my Desmos calculator here to solve this. So I've got 940 times the tangent of 53 degrees, and that gives me 1,247.4 feet. So I am going to go back to this. So the height of the building is approximately 1,247.4 feet. That's what that would look like. Okay. On number 6, we have, after takeoff, a plane flies in a straight line for a distance of 400 feet in order to gain an altitude of 800 feet. Find the angle of elevation from the ground to the plane. Okay, so these can get tricky because we have two kinds of distance. We have the distance the plane is covering this way as it ascends into the air, but we also have ground distance, which is along the ground, parallel to the ground. And then, of course, on this one, we have also been given this value. So our altitude is always going to be measured perpendicular to the ground. So that's going to be 800 feet right here. And you're told the plane takes off and flies in a straight line for 4,000 feet. So that's how we know that that's 4,000 feet instead of this side down here, because we're not told it's covering a distance along the ground. All right, we are finding the angle of elevation from the ground, that's right here, to the plane. The plane is right up here. So we are looking for the angle of elevation that the ground and the airplane would make. All right, so I am going to look at the relationship of x. I've got opposite and hypotenuse here. So I want the sine of x equals opposite over hypotenuse. And of course, I'm looking for an angle, so I'm going to use sine inverse of 800 divided by 4,000. So I'm going to go to Desmos here, go to sine inverse, and I'm going to have 800 divided by 4,000. And that gives me 11.5, and that is an angle measure, so I am going to approximate that as a whole angle, and it would be approximately 12 degrees. Okay, the next problem, we have a guy wire. Okay, don't freak out. It's not a guy and it's not a wire. And it's not a wire made of a guy or a guy made of a wire. Okay, a guy wire is a wire that holds something in place. Okay, so we have a guy wire attached to the top of a pole. So I have a pole right here and I have a guy wire. That's my guy wire right there. It reaches a stake in the ground 20 feet from the foot of the pole. Well, the foot is down here, so 20 feet would be on the ground, in the ground at 20 feet. So there's a little stake right here. So this is 20 feet. So there's my right angle. It makes an angle of 58 degrees with the ground. That is the guy wire that's making the angle of 58 degrees with the ground. How long is the guy wire? So we are looking for the length of the wire. So in relation to this angle here, we've got the hypotenuse and the adjacent side. So we are looking at a cosine of 58 degrees equals adjacent over hypotenuse. All right, this one's going to be a little trickier because I've got to cross multiply here, and I end up with cosine, or x times cosine 58 equals 20, and I've got to divide both sides by the cosine of 58 degrees. So x is going to be approximately, I'm going to go to Desmos, 20 divided by the cosine of 58 degrees gives me 37.7, and this would be in feet. 37.7 feet. Awesome. Okay, last one. From the top of a lighthouse, 160 feet high. Okay, so a lighthouse that's 160 feet high. There's an angle of depression of a boat at sea as an angle of 24. Okay, you have to be careful. The angle of depression from the top of the lighthouse is outside the triangle. And the boat is out here. I'm not an artist. I don't want any judgment. Okay, so there's the boat. So find the nearest foot, the distance from the boat to the foot of the lighthouse. So we are looking for that right there. Assume the foot of the lighthouse is at sea level. Okay, couple of options you can go with here. You can subtract 24 from 90 and get this angle right here, or you can use the idea that these are congruent And then you can use x to find, or you can use 24 to find the value for x. So opposite and adjacent, so I would use tangent of 24 equals opposite over adjacent. Cross multiply. Divide by tangent of 24. X is approximately, I'm going to use the Desmos. So I've got 160 divided by the tangent of 24. 359.4 feet. Magic.